So this is Objective 3.2, where we're talking about constructing equilateral and isosceles triangles and then using their properties. So these are two special types of triangles that we're going to explore today. Okay. So first word, some important vocab, opposite. We're going to use opposite in this lesson to mean across. It's really important to remember, like, let's say this side measure is 6, this is 7, and this is 8. Remember, the smallest angle is going to be across from that smallest side, and the biggest angle is going to be across from the biggest side. Okay, so this idea of like across, that idea is going to be important today. Angle is when we've got two lines or rays, segments connecting at one point. Congruent, oh, and then remember, sorry, the measure of an angle is the rotation it would take to close the angles on top of each other. And remember, we measure that in degrees. Congruent means same size and shape. Vertex is when we have an angle, so there's like an angle in a triangle here. I'm just going to draw a triangle to create an angle. And then where the sides of the angle meet, that's the vertex. And then base kind of refers to bottom. So we're going to explore equilateral triangles first. And so we talked about this a little bit in class, but just really quickly, if you like to play pool, I like to play pool, an equilateral triangle shows up when you rack the pool balls. So, because look at this. If when I rack all the balls inside of this, this becomes an equilateral triangle because look, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All three sides there are the same. So an equilateral triangle is a triangle in which all three sides are congruent, right? And notice the word equa showing up there. That's why we call it equa, to say kind of like equal. And each angle measure is going to actually also be the same. And so here, I'm going to draw myself an equilateral triangle down here. So if I have an equilateral triangle, all three sides are going to be the same. So notice I put ticks on each side length. And then all the angles are going to be the same too. So I'm going to put congruency marks on the angles. And like, think about why that would make sense. Like, back to this like idea of, we said like, the angles and sides in a triangle that are across from each other, like the sides of those correlate with each other. So like, if I've got an angle that's like this big, right? Like, I'm just putting these sticks on this angle here. And it's opening up, it opens up to form this side length, right? Well, if that angle is the same exact size, then this side length is going to be the same exact size. And then this angle is going to be the same, like this side is going to be the same exact size. Okay, so it makes sense that the three angles in a triangle would be 180. How I can find them is if I think 180 divided by 3, that's 60 degrees. Because 60 plus 60 gets us to 180 degrees. So an equilateral triangle, each angle has a measure of 60 degrees, which also means the equilateral triangles are equiangular, which is a fancy way to say all the angles have the same measure. Okay, so that's what's true about an equilateral triangle. So we're going to start applying properties to find stuff about triangles. So let's say we want to find the perimeter of this equilateral triangle. So the minute I read equilateral, I'm going to mark these three sides the same and these three angles the same. Now the perimeter is the distance around the outside. So that means I need to take however long ji is, plus jk, plus k to I. Now, how can I find how long one of these is? Well, let's just count boxes. The diagonal lengths, it's hard, you can't really count the boxes, but from j to I, you can count that it's 1, 2, 3, 4 boxes. So that's 4, and that means that that must be 4, and that must be 4. Because again, the triangle is equilateral. So 4 plus 4 plus 4 means that this triangle has a perimeter of 12. Okay? And then what's the measure of angle J? Well, if all the angles are the same, again, each angle is going to have to equal 60 degrees. Okay? Let's do another example. So this example wants us to find the values of x and y. All right, well, immediately I notice that the three sides are the same. So again, back to this idea of like, okay, if this side length is opening a certain amount, like this angle impacts the size of this side length. And if they're all the same, they're all opening up. Do you notice how like, oh, these angles must all be the same length if they're opening up to the same amount of side length, right? So all three angles are also going to be the same. So I like to just mark what I know about the picture first, and now let's build some equations. Well, to find x, what do I notice here? Well, I notice this is 12. Well, hey, that's going to be 12, and then that's going to be 12. All three sides are going to be 12. So that means 7 minus 2x has to equal 12. And so I'm just going to solve this for x now. You get negative 2x equals 5. Divide by negative 2, divide by negative 2, and get x equals negative 5 over 2. That would be x. Now, how do I find y? Well, again, if all three of these angles are the same, that means 60, 60, and 60. Right? So I can be like 8y plus 4, plus 4 equals 60. You could also add 8y plus 4 3 times to get to 180 and equal that to 180 because the three angles add up to 180. Notice the three angles add up to 180, not the three sides. So I'm not allowed to be like 7x minus 2x 3 times equals 180. But anyway, back to this. It's just shorter to be like 8y plus 4 equals 60. So I'll solve this equation. Get y equals 7. All right, so that's equilateral triangles. Now we're going to get into isosceles triangles. Isosceles triangles, we did a little soccer thing. We're going to skip that, and I'm just going to straight into what an isosceles triangle is. This is a triangle in which two sides have equal lengths. Okay? And so here's an example. Got an isosceles triangle. Now, two of the sides got to be the same, so I'll mark those two the same. Now, let's think about what will be true about the angles. So again, let's think about the angle that opens up to this side, right? So it's opening up to about that size, right? Right? Now, notice, if this side length is the exact same, then like the angle across from it also has to be the exact same, right? So if two side lengths are the same in a triangle, two angles are going to be the same too, and it's going to be those two angles opposite those congruent sides. And we have a special name for that. The angles opposite the congruent sides are base angles. Oh, sorry. I put this blank wrong. The angles opposite the congruent sides are congruent and are called the base angles. The other angle is called the vertex angle. So I'm going to like color code what I'm saying here. So like these are the base angles, and now this would be the vertex angle, which is different. Okay? And I want you to notice, like, imagine I draw another isosceles triangle, but I tell you these two sides are congruent. The base angles are going to now be at a different spot, because now, again, it's the angles opposite the congruent sides. So this angle is opposite that side. This angle is opposite that side. So those are the base angles. Those angles would be congruent. And then this would be the congruent angle. Now you might be thinking like, wait, doesn't base mean bottom? I mean, technically yes, but like, it's okay. The base angles don't always have to be on the bottom. Those base angles, again, are just the angles that are congruent, which are going to be opposite those congruent sides. If you just want to memorize like this image, right? If you want to always think about your base angles being on the bottom, I could think about rotating this triangle in my mind and notice how when I rotated it, it looked back like this picture. Okay, so like basically this triangle and this triangle, this is just like a rotation of that triangle. Does that make sense? Okay. All right, so now let's do an example. So example 3 says, which angles are the base angle and which is the vertex angle? So the base angles are those congruent angles. I notice these two angles are congruent. Okay, so it's going to be angle A and angle B are the base angles. The vertex angle is angle C. Okay, cool. Let going to also go further and say like, okay, if these are the base angles, then that means these two sides must be congruent to each other. And I'm going to like mark that. Okay. Which side is the base? Well, side AB is the base. Just happens to be on the bottom, the way this triangle is rotated. Okay. What is the measure of in degrees of angle C? Well, so if the base angles are the same, so I can do 54 plus whatever C is equals to 180, because the three angles inside a triangle add up to 180. So let me do that math quick. I'm bad at mental math. It should be 108, 180. So it'd be 76? No. 108. 72, my bad. So 72 degrees. Bam. Just a triangle sum theorem there. Cool. Now it's asking me what is the length of side CB. Well, I'm noticing side CB has a 7x minus 6. Well, if I want the actual length of side CB, I need to find what x is. So can I set up an equation? Well, 7x minus 6 has to equal 5x, right? They're congruent, so the sides are congruent, so like CB is congruent to CA. So 7x minus 6 has to equal 5x. You know what? Let me like write that down for you guys so you can see the setup of that equation better. So CA is congruent to CB. Therefore, 5x has to equal 7x minus 6. So when I solve that equation, I'm going to rewrite it over here to solve it. Sorry, I'm going to move my x's to the left side. By subtracting, get negative 2x equals negative 6. Divide by negative 2, divide by negative 2, get x equals 3. And so 5 times 3 is 15. 7 times 3 minus 6 is also 15. So the side length of CB is 15. I just plugged back into x. Okay, into those two side lengths up there. Why do the base angles have to be congruent if the sides opposite from them are? Again, it goes back to that side angle relationship in triangles, right? Like, basically, the angle opposite basically the angles have to be the same for the side lengths opposite to be the same. Like if one angle were bigger than the other, then one side length would be longer than the other. Maybe we add that in. One side would be longer or like different otherwise. Does that make sense? Like, again, if like these are opening up to the same amount of space, then these side lengths are going to be the same. If this angle were smaller, then notice that side length would shrink. And if this angle were bigger than that side length, then this side length would have to be longer. So that's why if the base angles have to be congruent if the sides opposite of them are. Okay? That's it. Hope you liked it. Philip would like to wish you a nice day. Have a good day.